Hello students, welcome to my channel. Today I will discuss about the periodic table. This is the last lesson of this topic. If you haven't watched the previous lessons, then I will share the link in the description box so you can go and watch those videos. So let's start the lesson. In this lesson, I will talk about the trains of some properties in the periodic table. First property is atomic size. Atomic size and atomic radius, the concept of these two terms is same. As I have told you in my previous video, that atomic radius is the distance between the center of the nucleus and the outermost shell of an atom. So, the atomic size is basically just the same. Atomic size depends upon the two factors, number of shells and nuclear charge. Let's take an example of period 2. These are the elements of period 2. Okay. Now, across the period, that means when we go from left to right of the periodic table, when we go from left to right of this particular period, period 2, then we will see that the number of shells remains the same. Why? See, in case of lithium, it's 2, 1. In case of beryllium, it's 2, 2. In case of boron, it's 2, 3. If we take the example of these three elements, particularly these three elements, like lithium, beryllium, boron. Electronic configuration 2, 1, 2, 2, 2, 3. So the total number of shells present in each of these elements is 2. 1, 2. Again 1, 2. Same is for boron. 1, 2. So the number of shells present in these elements is 2. So across the period, the number of shells remains the same, right? So as the number of shells remains the same across the period, so there is no change in the atomic size. But at the same time, the nuclear charge increases across the period. The nuclear charge increases across the period. What is nuclear charge? See, nuclear charge is the total positive charge that is present in the nucleus of an atom. If this is an atom, okay, let's make it this. If this is an atom, at the center a nucleus is present. In nucleus, protons and neutrons are present, right? Neutrons have no charge, so protons are the positively charged particles, right? So nuclear charge means it is the positive charge in the nucleus of an atom. Basically, it means the protons that are present in the nucleus. Now, nuclear charge increases across the period. From left to right, nuclear charge increases. So, if nuclear charge increases, then what will happen? This is an atom. This is the nucleus. These are the various energy shells of an atom, okay? Now, if the positive charge in the nucleus increases, then this positive charge will attract the electrons. There are electrons that revolve around these energy shells. So this positively charged nucleus will attract all these electrons that are present in the outermost shell. As a result, there will be decrease in the atomic size, right? It will contract. The size will contract. It will become lesser in size. So, across the period, from left to right, as the number of cells remains the same, but the nuclear charge increases across the period. So, as a result, all over across the period, atomic size decreases. So, the trend across the period of the atomic size is it decreases across the period. As we go from left to right, atomic size will go on decreasing. Clear? Now, if we look the same trend down the group, that means if we consider group 1, we will see down the group. That means from top to bottom. What will happen? Here, in case of down the group, if we take the example lithium, sodium, potassium. Let's take it example. See, lithium, sodium, potassium. Electronic configuration of lithium 2 1, sodium 2 8 1, and potassium 2 8 8 1. See, the more we are going down the group, right, from top to down, the number of shells is increasing. In case of lithium, it's 2. In case of sodium, it's 3. In case of potassium, it's 4. So, the number of shells goes on increasing down the group. That's why the atomic size also increases down the group. At the same time, the nuclear charge also increases down the group. So, what should happen? If nuclear charge increases, then atomic size should decrease. But in this case, when we go down the group, then what happens? As the number of shells is increasing, so the increase in the number of shell will dominate the nuclear charge. That's why all over the atomic size increases down the group. Clear? So the basic trend is atomic size decreases across the period, but it increases down the group. The trend is very important. You have to remember and you have to understand the reason of these trends very clearly. Why? Because the important questions come from these trends only. Okay. Now, next is I will be talking about three properties: ionization potential, electron affinity, and electronegativity. In all these three properties, the trend is same, and all these three properties depends upon two factors: atomic size and nuclear charge. Okay. Now what happens? Here also I am taking the example of period 2. As I have told you in earlier that atomic size, what happens? It decreases across the period, right? Just few minutes ago I told you that when we go left to right in a periodic table, then atomic size decreases. Now, in my previous video, I told you what is ionization potential. When an atom, suppose atom M, loses an electron, then an amount of energy is required to remove this particular electron from its outermost shell, right? That particular energy is ionization potential. Now, if the atomic size increases, then what will happen? The ionization potential will also increase, and nuclear charge is also increasing across the period. If nuclear charge is increasing, that means if an atom is becoming more and more, the positive charge is going on increasing, goes on increasing, goes on increasing. So the energy that will be required to remove an electron from the outermost shell of this particular atom will be more. So the ionization potential will also increase. So what happens? Across the period, that means from left to right, as atomic size decreases and nuclear charge increases, so all over the ionization potential increases across the period. When we go from left to right, ionization potential increases. As nuclear charge is increasing, so the positive charge in the nucleus is also increasing, which will attract the electrons present in the outermost shell more and more, which will become more difficult to lose an electron. More energy will be required to remove an electron from an atom. That's why ionization potential is increasing across the period. Clear? Now, the reverse is the case when we will see that same property down the group. What happens? when we go from top to bottom, the atomic radius increases, right? As a result, ionization potential decreases. And the nuclear charge is also increasing down the group. So, ionization potential should have increased if nuclear charge is increasing, but it is not the case. Actually, ionization potential will decrease from top to bottom. Why? Because here, as atomic radius is increasing, so with the increase in the atomic size, the nuclear attraction on the outermost electrons will decrease. As a result, less energy will be required to remove an electron from the outermost shell of an atom. So ionization potential is decreasing. This increase in the atomic radius is actually dominating. It is dominating over the nuclear charge. That's why when we go from top to bottom, ionization potential decreases. Clear? So this is basically the trend. And all these reasons are absolutely applicable for electron affinity and electronegativity. In all these three cases, the factors are same, the trends is same, and the reasons are absolutely same. Now, some questions, some important name the following comes from this portion. What is the element in the periodic table with highest electronegativity? The element is fluorine. You have to remember that. See, electronegativity, I have already told you in my previous video that it is the tendency of an atom to attract electrons to itself, right? So, we know that the elements that are present at the right of the periodic table, they are the non-metals. That means they are electronegative. So the highest electronegativity is fluorine. Noble gases, that means group 18 elements, they will have zero electron affinity and they will have highest ionization potential. What is the reason behind this? See, in case of noble gas, they are inert in nature. That means, suppose helium. 2 electrons are present in its outermost shell. So, it has already achieved the duplet configuration. There is no requirement for any other electron to lose or any other electron to gain. So, what is the meaning of electron affinity? Electron affinity is the amount of energy that is released when an atom accepts an electron. Helium will not accept an electron. Why? Because it has already 2 electrons. Its valence shell is completed. So there is no need for helium to accept 1 electron. That's why there will be no release of any energy. Electron affinity for all the noble gases is 0. Now, why ionization potential is highest in case of noble gases? See, ionization potential is the amount of energy that is required to remove an electron from an atom, from the outermost shell of an atom, right? Helium already has 2 electrons. There is no need for losing any electrons from the outermost shell. If we try to remove an electron from the outermost shell of an helium, then we need more and more energy for removing that electron, because we will forcefully remove that electron, because helium will not give you the, or it will not, it is not ready to give electron. Already it has achieved duplet. So there is no need to lose an electron. So we have to forcefully remove the electron from helium. That's why more energy will be required. So highest ionization potential is found in case of noble gases or group 18 elements, right? So this is the trend for all these 3 properties. Next is metallic and non-metallic character. In my previous video, I have already told you about the metallic and non-metallic character. Metals are present at the left of the periodic table. They are electropositive. That means metals will lose 1 or more electron to become unipositive, right? And
non-metals are present at the right of the periodic table, they are electronegative because non-metals will gain one or more electron to become anion. Clear? Now, what is the trend? The most metallic character we will find in the left. So, metallic character decreases across the period. And the reverse will be case in case of group. It increases down the group. Opposite will be the non-metallic character increases across the period and decreases down the group. These two character also depends upon the two factors, atomic size and ionization potential. Okay. Atomic size, we know atomic size, what happens? Both the atomic size and ionization potential are the factors on which metallic characters and non-metallic character, both these two properties, they depend upon these two factors. Now, next is density, melting point and boiling point. These three properties, you can say these three are the physical properties. Now, density and melting point. Density and melting point, these two physical properties, they increases gradually across the period. Across the period, suppose this is a periodic table. From left to right, density and melting point, they both increases gradually. They reach a maximum value and after that they will slightly decrease. The value will slightly decrease after reaching a maximum value across the period only. Okay. And in case of down the group, density increases gradually down the group, but melting point and boiling point, they decreases gradually down the group. This is the trend. You have to remember the trends because questions often come from this trends portion only. Next is the nature of the oxides, hydroxides, oxyacids and hydrides. See, in case of oxides, across a period, basic to acidic, the change is from basic, strongly basic to strongly acidic, and the reverse is in case of down the group. So, in the left of the periodic table, we will find strongly basic oxides, and at the right, we will find strongly acidic oxides. In case of hydroxides, it is from strongly basic to amphoteric. And in case of oxyacids, from weak to strong, we will get weak oxyacids at the left of the periodic table, and at the right we will get strong oxyacids. Hydrides also, what we will get, same as oxides, strongly basic hydrides we will find at the left of the periodic table, and strongly acidic hydrides we will find at the right of the periodic table. So these are the few trends of some important properties that are found in periodic table. These trends are very important. You need to remember these trends. Now, another thing which is very important for board exam, especially for Icse, you have to remember first 20 elements of periodic table. That means from hydrogen to calcium. These elements you need to memorize because this will not only help in this chapter, but also it will help in a chapter known as chemical bonding. There you have to draw the electronic configuration of these elements. So if you remember these elements chronologically, not like hydrogen, beryllium, lithium, sodium, not like this. We have to chronologically memorize this. Like hydrogen, then helium, then lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, like this. That means according to their atomic number, you will memorize the name. By this, what will happen? You will be able to remember the atomic number of a particular element, and as a result, it will help you in drawing the electronic configuration or electron dot structure. I will be discussing about that in some other video. So you have to remember first 20 elements in periodic table for your board exam. Okay. So this is all for this lesson. This is the last lesson of this particular topic. I will upload the videos of some other topic very soon. Till then, stay tuned to my channel. And if you think my videos are informative and helpful, then please like and share my videos. Don't forget to subscribe to my channel. And thank you for watching the video.